Hello everybody and welcome back to Advanced Maths. Today we're looking at 3D coordinates and we're going to also look at some exam questions about 3D coordinates. Here we have our first example and it says consider the following cuboid. And on the cuboid we've got the vertex G labelled 0, 5, 6. And we've also got the vertex A labelled 10, 0, 0. And for this question, we are asked to state the coordinates of C, B, E, and F. Find the coordinate of the midpoint, find the distance between A and G, and also we're asked to find the angle between the plane OABC and the line AG. So it's a very busy question, lots of things to be working on. Let's start with part A. And here we're asked to find the coordinates of C. So C is in the bottom left, and we're going to try and find the value of C. And C is on the y-axis. This means that the value of x and z will both be 0, and only the y-coordinate will be non-zero. So we know that x and z will both be 0. And we want to find the y-coordinate. Okay, so we know that C is lined up with the coordinate 0, 5, 6, because it's on that same edge. And so therefore the y-coordinate will be 5, because it's lined up with 5. And then the x and z will be 0. So we get 0, 5, 0 here. That is the coordinate of C. Now let's look at B. Where is B? B is in the bottom right. And B is lined up with A and it's lined up with C. And so it's going to have the x-coordinate of A, and it's going to have the y-coordinate of C. It's got no height to it. So the z direction is not going up at all. It's just gone across the x and across the y. It's not gone up the z at all, so the z-coordinate will be 0. So we combine these and we get 10, 5, 0. It's lined up with the x, it's lined up with the y, therefore the x-coordinate is the same, therefore the y-coordinate is the same. E. E is above A, and so that's going to help us. I think the x-coordinate will be 10. But I'm also going to find D on my way. So let's find out what D is. D is going to be on the z-axis. And D is going to look like this. It's going to be 0, 0, 6. It's just on the z-axis, so D is 0, 0, 6. Now, we know D and A, and those both line up with E. And so we can see that the coordinate of E will be 10, 0, 6, like that. So the x coordinate comes from A, the z coordinate comes from D, which we found from G, and then the y coordinate is 0 because it's not coming towards us at all, it's staying in line with the x and z axis, like that. So we get 10, 0, 6 there. Now finally F. F is combining E, G, and B. So when we combine E, G, and B, we get that the x-coordinate is 10, the y-coordinate is 5, and the z-coordinate is 6. So we get 10, 5, 6, like that. And that's just coming from B, E, and G. Okay, so when you're finding these coordinates, just use the fact that it's lots of right angles on a cuboid, and all the coordinates do line up with each other when it's displayed like this. Okay, we've managed to find those coordinates. Now let's have a look at the midpoint. What is the coordinate of the midpoint M? We can see that M is halfway between G and F. And so it's going to be midpoint of G and F. And you can see that G and F are very similar. They've got 5 and 6 as the y and z coordinates. Only the x coordinate is different. So you have to go halfway between 0 and 10, which is like this, 5, 5, 6. That's the midpoint between G and F. What is the distance between A and G? Well, here we're going to use the distance formula. And for this, we use this formula here, x2 minus x1 squared, y2 minus y1 squared, z2 minus z1 squared. This is given to you in your formula booklet in IB Maths. And our two coordinates are here, A and G, and the x coordinates goes in, the y coordinates go in, and the z coordinates go in. It looks like this. We substitute the coordinates in like this. and this is our midpoint formula in action. And when we type that into a calculator, we get 12.688, which is rounding to 3 significant figures to 12.7. That is the distance. And so the distance between A and G looks like this, and that's 12.7. Now part D, it says, what is the angle between the plane OABC and the line AG? Okay, so let's first start by thinking about what the plane OABC is. So OABC is this shaded plane here that looks like that. It's just a flat surface, and it's normally a rectangle that is flat. That's what the word plane means. It means flat. Now we're interested in the line AG. We've already got the line AG from part C. And we also know that the line CG is 6 because the coordinates are 0, 5, 0 and 0, 5, 6. The only difference is 6. So therefore the line C to G is 6. Now C is directly below G, and that's why we care about C. So on the plane OABC, the only point that is below G is C, and so C is the point we choose to care about. We don't care about O, we don't care about B, because they are not underneath G. A is where we draw the line from, and that's also on the plane, so we do kind of care about A. But C and G are directly over the top of each other, so that's where we start drawing angles from. So we draw the line C to A, and then we get this angle here. And that's the angle it's talking about. And again, just to emphasize that, I got that by realizing that C and G are on top of each other, and therefore that's the angle I draw, CAG. Now this is useful because now I have two lengths of that triangle, and I also can see that this is a right angle triangle because it's a cuboid, and the height of a cuboid is perpendicular right angles to the base of the cuboid. Fantastic. So we've got all the information ready now, and we've broken this down to find the size of that triangle, the size of that angle of that triangle. And so we'll take this triangle and we'll draw it again to the side so we can focus on this triangle. Now it's just a matter of SOHCAHTOA. We've got the opposite and the hype. Sine of the angle is opposite of hype. Put the numbers in like this. Do the inverse sine. And when you type that into your calculator, you get 12.2 degrees. The angle is, 28.2 degrees. 28.2 degrees is the final answer. And that's it. That's all of question 1. Let's now have a look at question 2. It says, consider the following square-based pyramid. The height of the pyramid is 7. What are the coordinates of the vertices? What is the angle CAE? And what is the volume of the pyramid? Okay, let's start with part A, and we're going to try and find the vertices. And we know this is a square-based pyramid, so therefore we can use the fact that all sides of a square are equal in length to know that that is 5, therefore all other lengths are 5. Therefore, this coordinate is 8, 5, 0. It's 8 across and 5 out, so the distance is 5. That coordinate is 3, 5, 0, and now we have the 4 coordinates of the base, which are all a distance of 5 from each other. And it's really easy that because they are lined up with the x and y axis. Now the height of the pyramid is 7, so we're going to use that and the midpoint of CA to find the coordinates of E. So let's find this midpoint of CA first, and halfway between C and A, we average out the coordinates. Half, we do 3 plus 8 is 11, divided by 2 is 5.5. 5 plus 0 divided by 2 is 2.5. We add the x coordinates together, divide by 2, add the y coordinates together, divide by 2, add the z coordinates together, divide by 2. We average out all the coordinates, and we get 5.5, 2.5, 0. And that is the midpoint of the base. Now, we know the height of this is 7, because it says so in the question. So the coordinate of E is 5.5, 2.5, 7. And we found the coordinates of E. Good. Now, part B, it says, what is the size of angle CAE? And here I'm just focusing on CAE. I've got rid of the other coordinates. And I draw that angle. So from C to A, and then A to E, we get this triangle here. And one way to do this is by doing the cosine rule. And in the interest of time, I'll just tell you that by using the distance formula, we get the size of all three of those lines. I won't do that distance formula on the video because it'll take too long, but basically I'm just putting numbers into distance formula and I get these values here. I've skipped that step in the interest of time, but that's what I did. I just put the coordinates into distance formula of all three and I got those values there. Now focusing on this triangle here, I can use the cosine rule. I want to find this angle here, and I use the cosine rule like this. Cos of A is equal to B squared plus C squared minus A squared over 2BC. I have a video on the cosine rule if you need to refresh, and I will link that in the comments below. I put the numbers into the cosine rule and I solve, and I get 67.5 degrees. If you got the CG50, you can do solve n on that, and that will solve it for you. That's one way, 67.5. Let me show you another way to deal with that question. So if I halved the length of 7.071, that blue line on the bottom, if I half that, I would get a right angled triangle here like this. I get 3.536. I would get a right angled triangle like this. And this would avoid using the cosine rule. This would now use the SOHCAHTOA. And I'd take that triangle, I would do inverse cos, and I would get 67.5 again. So there's two different methods there, and both of them work. Now, part C, what is the volume of the pyramid? Okay, this is very easy because we know that the height is 7, and the area of the base is 5 times 5, which is 25. The volume is a third times base times height. That's a third times 25 times 7, which is 58.3 units cubed. And that's the final answer. We've done question 2. Well done. I hope that worked for you. But if you'd like to watch the video again, just rewind and watch the bits you didn't understand. There was a lot of information in today's video, and rewatching is completely fine. Thank you for watching today's video from Addvance Maths. Remember to like and subscribe for future videos. Please also share this video with your classmates or anybody else who's studying maths. I'm sure they would find it useful. If you'd like more resources for IB Maths, check out advancemaths.com for more free revision resources. Thank you for watching and good luck in your exams.